Romantic love is often described as one of the most intense emotional experiences in human life. It brings excitement, attachment, and for many people, a sense of transformation. But beneath this emotional landscape lies a complex set of biological and psychological processes that alter how the brain functions. In this episode, we explore what recent research reveals about the impact of romantic love on the brain, why it can disrupt our thinking, and how these changes shape the way we behave. Human relationships have always relied on emotional bonding, but modern neuroscience now allows us to observe what happens inside the brain during the early stages of romantic attachment. One of the most consistent findings in recent studies is that falling in love activates the brain reward system. Particularly regions respond to highly rewarding stimuli and release dopamine, a neurotransmitter associated with pleasure, motivation, and anticipation. When someone falls in love, dopamine levels rise dramatically, creating a sense of exhilaration and sustained focus on one specific person. This response is not accidental. From an evolutionary perspective, dopamine driven attraction encourages humans to form stronger social bonds. However, this chemical surge also changes the way the brain prioritizes information. When dopamine levels increase, attention becomes narrowed. The mix fixates on the loved one, often ignoring other responsibilities or risks. This explains why early stage romantic love can feel obsessive or overwhelming. Individuals may experience intrusive thoughts, reduced appetite, and difficulty focusing on tasks that previously seemed simple. In this state, the brain is not functioning in its usual balanced manner. It's operating under a heightened reward signal. While dopamine intensifies desire, other neurochemicals shape the emotional and physical sensation of love. Oxytocin and vasopressin hormones released during moments of intimacy and closeness enhance feelings of safety and connection. These hormones strengthen attachment and help form long-term bonds, but their influence also shifts emotional regulation. When oxytocin levels are high, the brain becomes more trusting, more open to vulnerability, and less sensitive to potential social threats. Also, this supports relationship building. It can also reduce analytical thinking, making individuals more likely to idolize their partners or overlook negative behaviors. Another important component of the neurobiology of love involves stress. Surprisingly, many studies show that the early phase of romantic love elevates stress hormones such as cortisol. This elevation produces physical symptoms like increased heart rate, nervousness, and emotional instability. The coexistence of dopamine induced pleasure and cortisol driven stress creates a unique psychological state. People often describe early romantic experiences as both exciting and unsettling. And modern research confirms that this mix of emotions comes directly from changes in the brain's chemistry. These biological changes also affect cognition. Functional MRI studies reveal that during romantic affection, activity decreases in brain regions associated with critical thinking and social judgment, including parts of the prefrontal cortex. This reduction does not imply irrationality in the traditional sense, but it does indicate that the brain temporarily deprioritizes analytical processes. The purpose is to facilitate bonding, not to maximize accuracy. As a result, individuals may misinterpret signals, underestimate risks, or make decisions driven more by emotion than by conscious reasoning. Love also influences perception. Studies published in recent years show that romantic attachment alters how the brain processes faces, memories, and emotional cues. The attentional magnet automatically capturing mental resources. Visual attention becomes biased. Memory becomes selective, and emotional significance becomes amplified. This phenomenon explains why small gestures from a romantic partner can feel disproportionately meaningful, and why neutral events can take an emotional vein during this period. One of the most striking findings is that romantic love changes the brain's prediction system. The brain constantly makes predictions about social interactions, rewards, and treats. When love begins, these predictions become heavily skewed toward positive expectations. The brain anticipates reward, closeness, and emotional fulfillment, even when evidence is limited. This predictive bias can make love feel transformative, but also destabilizing because the brain is temporarily operating under assumptions that may not reflect reality. As relationships continue, brain activity gradually shifts. The intense, dopamine-driven attraction of early love evolves into a calmer form of attachment characterized by emotional stability and long-term bonding. During this transition, the brain reduces activity in the reward system and increases patterns related to trust, empathy, and companionship. Also, the emotional intensity may decrease. The sense of security often becomes stronger. This shift shows that love is not a single emotion but a dynamic neurobiological process with multiple phases. Understanding these processes does not diminish the value of love. Rather, it helps explain why romantic experiences can feel so powerful and sometimes so confusing. Love affects decision making, attention, memory, and emotional regulation. Not because individuals lack discipline, but because the brain is biologically programmed to respond this way. The disruption that love creates is part of a natural system designed to support connection and cooperation. Recognizing the brain's role can help individuals navigate relationships with greater awareness. Knowing that early love enhances idealization may encourage more careful decision making. Understanding the stress hormones rise in the beginning can normalize emotional turbulence. And realizing that attachment grows through biological mechanisms can foster appreciation for both the emotional and scientific aspects of intimate relationships. Romantic love influences nearly every major system in the brain. It can be uplifting, destabilizing, joyful, and stressful at the same time. Its power lies not only in emotion, but also in biology. And the more we understand its effects, the better we can appreciate how profoundly human it is.